Electromagnet is a type of magnet in which the magnetic field is produced by an electric current. Here we can talk about the general electromagnets used for everyday purposes. They are used in a wide variety of applications, such as the industrial electromagnets, which are used to lift heavy objects. Electromagnets have some advantages over permanent magnets. For example, they can be turned on and off whenever we want it, and the strength of the magnetic field can be varied. These properties make electromagnets useful for picking up scrap iron and steel in scrap yards. There are thousands of other uses as well as of them. So in this experiment, we learned to create our own small electromagnets and to investigate the effect of numbers of coils around the core on the strength of the electromagnet.
The material used are battery, copper wire, scissors, and staplers. The scissors will act as an iron core.
Procedure. All the materials are prepared. Then, leave about 5 inches of wire loose at one end and wrap most of the rest of the wire around the scissors. Cut the wire so that there is about another 5 inches loose at the other end too. Then, remove about an inch of the plastic coating from both ends of the wire. Attach the one wire to one end of the battery and the other wire to the other end of the battery. Now, the electromagnets are produced. Then, put the point of the scissors near a few of stepper bullets. Lastly, observe the result.
So how does electromagnetics work? When an electric current flows in a wire, it creates a magnetic field around the wire. This effect can be used to make an electromagnet. A simple electromagnet comprises a length of wire turned into a coil and connected to a battery or power supply. When current passes through the wire, it creates a magnetic field which is concentrated at the center of the coil. The magnetic field disappears when the current is turned off. The wire turns are often wound around a magnetic core made from a ferromagnetic or ferrimagnetic material such as iron. The magnetic core concentrates the magnetic flux and thus makes a more powerful magnet. So in this experiment, the current emitted from the battery to the coils magnetized the scissors so that it could attract the stapler bullets. The strength of electromagnet depends on how many times the scissors was coiled. The more the numbers of coils, the more the magnetic force. The wires are coiled around the scissors such that the lines of magnetic force are parallel and pointing in the same direction. Every coil of the wire increases the magnetic flux density of the electromagnet.
Through this experiment, we observed that the number of attracted staplers is increasing when the number of turns of copper coil increase. As a conclusion, we can say that the strength of electromagnet is directly proportional to the number of turns of copper coil when the iron core and the battery used in the experiment is unchanged.